Hello there students, welcome to a continuation of our Motion in One Dimension series, and in today's video we'll be looking at practice problems. Alright, so in this problem we're given our position as a function of time given by 3t cubed minus 10t squared plus 4t plus 8. And the first part of this problem asks us to calculate the velocity at t is equal to 2 seconds. And the second part of this question asks us to calculate the acceleration at t is equal to 2 seconds. Alright, in the previous video, we've already covered that velocity is the derivative of position with respect to time. Let's write that down. So we know that velocity with respect to time is the derivative of position with respect to time. And so for us to get the velocity, or for us to be able to solve the first part of our question, we need to find the derivative of the position with respect to time, and that will give us our velocity. Alright, so I'll just erase that and I'll write it in this way. So the derivative of position with respect to time will give us the velocity. So writing that down, we have 3t cubed minus 10t squared plus 4t plus 8. And we'll be finding the derivative of this function. Alright, so we've covered that the derivative of position with respect to time will give us velocity. And so we already have our velocity with respect to time. And finding the derivative of this function, we'll use the power rule, where we'll multiply the exponent by the base and then we'll subtract the exponent by 1. And so multiplying 3 by 3, we'll have 9, and then if we minus the exponent by 1, we'll have t squared, and I'll do the same for all of these values. And so if we multiply 2 by 10, we'll get negative 20, and if we minus by 1, we'll have t. And so doing the same for this value, we'll have 4, and we know that the derivative of a constant will just give us 0. Alright, and so we've now derived, or we've gotten the expression or the function of velocity with respect to time by finding the derivative of position with respect to time. Okay, and so the question asks us to find the velocity at t is equal to 2 seconds. So it means that I'll have to substitute 2 wherever I see t. Or it means that I'll have to find the velocity at t is equal to 2 seconds. And so substituting 2 wherever I see t, I'll have 9 multiplied by 2 squared minus 20 multiplied by 2 plus 4. 2 squared gives us 4. 4 multiplied by 9 gives us 36. Minus 20 multiplied by 2 gives us 40 plus 4. 40 minus 4 will give us negative 36. 36 minus 36 will give us 0 meters per second. We have now found our velocity at t is equal to 2 seconds. I'll write it over there to make space. Let us now cover the second part of our question. Okay. We need to remember that in the previous video, we found out that, or we covered that acceleration is the derivative of the velocity with respect to time. Let's write that down. So acceleration with respect to time is equal to the derivative of the velocity with respect to time. Okay, so what this means is that to find the acceleration, we'll have to find the derivative of our velocity function with respect to time. So let's just do that right now. And so writing this function down over here, I'll have 9t squared minus 20t plus 4. And we're finding the derivative of this function with respect to time. And so we already know that the derivative of the velocity with respect to time will give us the acceleration. Okay, if we use the power rule, we know that 2 multiplied by 9 will give us 18. And if we say 2 minus 1, this will give us t. We'll do the same thing over here. Remember, there's a 1 over there. And so if we multiply the exponent by the base, and then we'll subtract the exponent by 1. And so 1 multiplied by negative 20 will give us negative 20. And 1 minus 1 will just give us 0. Alright, so which means that it will just give us 1. And the derivative of a constant is 0, so we'll just let it be. Okay, and so now we have found the function of acceleration to be 18t minus 20. To calculate the acceleration at t is equal to 2, we'll have to substitute, wherever we see t, we'll have to substitute 2. And so if we substitute 2, we'll have 18 multiplied by 2 minus 20. 18 multiplied by 2 gives us 36 minus 20. 36 minus 20 will give us 16 meters per second per second. We have now found the acceleration at t is equal to 2 seconds.